let me introduce myself as I continue to fix this, because I know time is far much spent, and also talk about probably what we expect to learn today. So my name is Maxwell Oyaro. My background is in electrical and telecommunication engineering. That is what I did in my first degree. I did a master's degree, which is not related to technology at all, in power engineering, specialized in jet turbines and internal combustion engines. Graduated 2 years ago, but I've been in the tech space from since around 2018 is when I started doing DevOps. I've been a DevOps consultant since then, doing freelance mostly, but lately I joined Greenpeace International as a site reliability engineer. So that is who I am, and that is the brief of what my background is. Mainly, I do consultancy in cloud computing, DevOps, SRE practices, solution architecting, especially for microservices in the cloud. I mostly use Google Cloud and AWS, but I'm trying also to get up to speed with Microsoft Azure. So today we are going to talk about version control systems, and basically we are going to look at Git, which is the most commonly used version control system, and then we're going to look at GitHub, which is basically a platform where we can host our repositories in the cloud. Great. I think let us go straight let's go to the next slide. So basically for this, all you need is your GitHub accounts. Yes, and these are the learning objectives for this particular presentation. I thought to myself and said, it is from my conversation with Julia and Doris, I was told that most of us here are beginners. So I wanted something which is straightforward and clear to grasp the concepts of what Git and GitHub is and how to use it basically. And therefore, I narrowed down to these learning objectives for this particular presentation. And I'll try to make it as quick as possible so that we can go ahead and do a demo to actually know that you can be able to do this. So basically, you're going to learn how to open a repo using github.dev, create a branch, commit changes to the branch, create a pull request, merge the pull request, and delete the branch. So basically, this is sort of what you will do on a daily basis when you are collaborating with other developers in a project. You will create a branch, add your features, commit your features, the changes that you made to your branch, create a pull request, somebody approves it, and then you merge the pull request, and then you will delete the branch because it is no longer, if everything has been accepted into the main branch, then you will no longer need to have it. So basically, that is what we're going to see and why this is important. Can you kindly go to the next slide? If everything that I've said looks very new to you, don't worry. By the end of this, you will understand what all these things mean. So the agenda is introduction. What is GitHub? Work in github.dev. We'll have a small quiz at the end to test if we have understood what we've done, and then we'll have a small summary of everything. Next slide, please. So what is GitHub? I'm sure you've heard what Git, GitHub, sometimes GitLab, sometimes you've heard all these terms. What is the difference? What is GitHub? What is Git? What is GitLab? Can somebody try to define these things before I can actually give my definition of what I think it is? Anybody from the meeting? Well, let me define these terms. You can actually write in chats if you may not be able to talk. But basically, Gregory Opondi, can you go ahead, please?
Okay, I can try. So Git is what is called a version control system. So it's a way in which you're able to keep track of the changes you're making in your file or in your program. And then I think GitHub and GitLab is now a way you can, I don't know, share them through the cloud or something like that. You can also see other people's projects and repos and things like that.
Yeah, that is true. Thank you for that. Thank you very much. That is actually what it is. Git is the version control system. It helps you to version your code, to know what changes you've made. You can roll back to a previous version. It helps you do all these things. On the other side, GitHub is actually a cloud-based hosting system where you host your code remotely so that everybody else can actually see the code that you're working on. So it enables you people to share in a cloud-based environment. And basically that's what GitHub is. But as GitHub continues to grow, it has evolved to be more than just that. There has been things that have introduced like Github Actions, which is actually a tool for continuous integration that you can actually use now GitHub to continuously test your code as you commit it onto GitHub. So that if you made a change to a branch, you can actually test it on GitHub. Yeah, so it acts sort of like an automation server to some extent. On the other side, GitLab is a full package. Actually, GitLab is more complicated, and it is, apart from it being a hosting platform for your code and everything, as GitHub is, GitLab also offers a full end-to-end solution in the software development ecosystem. That is why GitLab can be used actually also as for secrets management. For example, you can do your secrets management through GitLab, because it really integrates very well with some tools like HashiCorp Vault. You can use GitLab also to do things like infrastructure management. You can manage your infrastructure as code. GitLab has a very deep integration and very good API plugins with Terraform, to be specific, which is nowadays like the de facto tool for cloud infrastructure management in terms of provisioning. Also, GitLab has a very deep integration with Kubernetes. So you can even manage your Kubernetes clusters just through GitLab. And GitLab also, it has been built in such a way that it has even very good dashboards that can help you manage your software development team in an agile environment. Using the agile methodologies, it has very good boards that actually you can use for Kanban and Scrum. So that is what GitLab is. GitLab is end-to-end. You can do everything that a software development team does basically on GitLab. So that is the difference, Git, GitHub, and GitLab. But of course, GitHub, it was actually acquired by Microsoft, I think in the last year or so. And they have tried to integrate Azure DevOps into GitHub, and also GitHub Actions, which is now a product of Microsoft, is also part of GitHub. So all these things have just, so GitHub is also actually trying to become like sort of what GitLab is. But for today, we are not going into all those details. We want to look at what GitHub is basically and how you can use it to collaborate with other developers through GitHub. Next slide, please. So we have what we call the GitHub Flow. The GitHub Flow is basically a way, like a generic way which has been defined to collaborate with developers on GitHub. Yeah, GitHub, as I have already said, apart from it being a platform for collaborative software development, it also offers a workflow designed to optimize use of its various features, which I've already said, like GitHub Actions, which is now a feature that has been added. It is now being integrated, I think, very nicely with Azure DevOps. If you don't know these things, don't worry. You will know by the end of this 3 months period. All these things will be you will be very comfortable with them, and you will understand what they are. So, and this is what we are going to spend most of our time doing today, is to go through a GitHub workflow. Yeah. And it's so unfortunate. So I don't know how we're going to do the demo because I wanted to do it from my computer so that you can see, but I think Julia can help us get this GitHub workflow flowing. Next slide, please. So as you work with Git and GitHub, you may wonder about the difference between the two. I have already said that. Git is basically installed and used on your local machine. It handles version control and also supports branching, which is actually what makes collaborating on code possible. It is actually branching. Yeah. On the other hand, GitHub, it has many things. This is where you can define your projects, you discuss, you make your comments on somebody's code and what he has done. You can create pull requests. On different platforms, they will use different names. On GitHub, it is a pull request. But on something like GitLab, it is a merge request. But it is basically a way of actually contributing into a project. You would actually use a pull request on GitHub. You can use it for notifications. You can use it to notify people, oh, I have made some changes. I have pushed them to the remote repo. Have a look, and you can actually integrate that to your Slack channel for the team, and they see. You can use it to label your stuff, whatever you're working on, a project. Let's say, as you go into a team, you will realize like there are always 100+ projects or things that you're working or features you're working, for example. So you can do labeling so that you can sort that project appropriately. GitHub helps you do that. There's GitHub Actions, which is basically a CI tool, continuous integration tool. And you will hear me talk about these things so much. It is because they actually is what I do every day, the CI/CD things. Forking is when now you want to use somebody's work for your own. GitHub, there are like so many open source tools that are on GitHub. Now you can fork those tools, those resources and those codes, and actually you can tailor them for your particular use case. Yeah. So if let's say somebody has made a plugin that integrates two different SaaS tools, software as a service tools. For example, I have made a plugin that integrates my Google Calendar with what we use at our workplace for CRM. So, and I've put it on GitHub, and you want to use the same because maybe you're using the same tools. You can actually fork it, add in some code into it so that you can tailor it for your own use and use it. As long as it is open source and it is publicly shared, you can actually fork. But now if you want to contribute or add a feature to it, you don't just fork it, you will have to have a pull request, which will now enable you to contribute to these open source tools that are many. Actually, there are so many on GitHub, as you will see. And then next is the point of projects. It is on GitHub where you will define your project scope. Sometimes you may even in that project have things like what is the definition of done. If you are using, for example, an agile methodology, it has some questions that you ask. What success of these projects look like? What is the definition of done for the project and stuff like that? So you can up this in the project so that everybody who is working on the project, he knows like, this is where we are going. This is the definition of done for this project. If we achieve this, if this code that we are writing can do ABCD, then we can say that the project has been done. So that is basically the difference between Git and GitHub. So Git is basically a version control system, but GitHub is a platform that does so many things, allows you to collaborate with your guys, discuss notification and all those things that I've listed to the right. So next slide, please. So branches are the preferred way to create changes in the GitHub flow. Yeah. This is the most important thing. If you will not learn anything from this presentation, at least learn this process, because this is the whole thing. The whole reason why we have all these things is actually for collaboration, yeah, and to track changes. And branching or branches are what makes it. If somebody is asking if the VS Code setup wizard is needed, yeah, it may be needed for a demo. We'll talk about that after this shortly. So this is the best practice, yeah. In a project, there is always the main branch. Some people call it the master branch. I think in GitHub, it is main branch, and in GitLab, they prefer master branch. So the best practice is usually that the master branch is production ready. Is always production ready, yeah. The master branch, the code that is on the main branch, is basically the code that is running in production. Yeah. Now, if you want to create another code, okay, I see yours as master branch as default. I think that is, you are the one who has set it like that. You can set your default, which is okay. So for you to add a new feature into what is already in production, you would do that through a branch. You would create a branch from the main branch. Yeah. There is this concept of source and target branch. Your source branch should actually be your main branch. So you branch from the main branch and create the feature branch that you're working on. So you add your code or your new feature into this new branch that you've created, yeah? After you've made that branch, you commit changes to that branch. After committing changes to this branch, we will shortly see how that is done. Now you will create a pull request. A pull request is basically saying, guys, I've added some code to the main branch and I've done it through this branch. I want this to be added into the main branch. So kindly, can you look at this and approve it so that it can go back to the main branch? So basically, if you are a junior dev, you will do this, and a senior dev will review what you've done. And in a DevOps environment, this would even mean that as you create your branch, actually the CI/CD pipeline kicks off. When you commit your changes into that branch, they are tested. They run through all the automation tested is done, and you will have your result even before you submit a pull. You submit your merge request for. No, I see Ian is raising your hand. Just a minute, I'm giving you a chance. Immediately you make a pull request. After committing your changes, immediately you make a pull request in a CI/CD environment. Your code will be tested immediately, and you will have your results if your code actually passed the tests or it is haiko sawa. So if it is not okay, you will know even before the senior dev looks into your code. Yeah, and shortly I will be talking about Git Hooks, which are a way of actually doing that, not on even GitHub. You can do that on your local machine. Even before you commit your changes into the repo, you are able to know that your code has a problem or not. And that is usually encouraged, especially now that we are shifting left in terms of security and ensuring that we can capture bugs as early as possible in the software development ecosystem. So, life cycle. So, I will be talking shortly about that. So basically, this is what happens. You will create a branch, commit changes to that branch, submit a pull request. On that pull request, people will comment on your code. They will review it. If it is okay, everything looks good, it has been tested, it is okay, it will be merged to the main branch. And once that has been done, there is no need for us to have this extra branch that you created. It is supposed to be deleted automatically so that we remain with one branch, which is deployable into production. Is everything clear up to this end? I will give you a chance to ask a question. You raised your hand. Doris is asking, what is CI/CD? Well, I will take both questions and then answer them at the same time. CI/CD stands for continuous integration and continuous delivery. Continuous integration means that you set up your software development workflows in such a way that as a developer, when I make changes when I have code that I've written or I've contributed to code, like through this branch, immediately I commit my changes and submit a pull request, my code is actually tested immediately using an automation server. It can be Jenkins, it can be GitLab, it can be Circle CI, it can be Github Actions. There is some stuff you need to do to this particular automation server, for example, Jenkins or GitLab, so that there are some configurations you do. You write a pipeline. There's some code that you write, such that, and when you submit your code and you commit changes and create a pull request, your code is actually tested immediately. Yeah, and in CI/CD, that is CI. CD means if the code now passes all the tests that are actually there, there is no need for somebody to come and approve it and click say everything is okay, nini nini. You can set your automation server so that it is automatically approved and merged into the main branch. After being merged into the main branch, it is actually deployed into production without human intervention. Yeah. And this is becoming the new way of doing things and the most adoptable way of doing things. We are moving from the waterfall software development cycle style of doing things. We are moving into more agile practices where we are using Scrum, we are running sprints, and we are actually deploying stuff into production multiple times a day. For this to happen, the process actually should be automated. So CI/CD basically is about automating your software development lifecycle and increasing the speed of software delivery into production. That is what it is about. Yeah. For example, now that I'm in SRE, um, SRE is basically treating operation what initially used to be done by system admins using software development principles. So, like in a team where I work, our sprints are 4 days long. So we channel out stuff into production, features into production every other 4 days. And this can be a features like normally we are adding like every week an average of 60 features because there is always something to add in this software development as you will learn. It is a very fast-paced environment. Actually, things are very fast, especially now with DevOps and SRE. It is very fast. I know in other teams that use Sprint Scrum, it is normally 4 weeks. But if you go into SRE teams that use Scrum, from my consultancy and what I have seen, it is usually 1 week or less. So you're moving your stuff into production every other day. You are fixing bugs every day. There are bugs to be fixed, and how do you fix this? They're like you need to fix bugs like every other day, like 10 bugs in your team. How is this possible? It is possible through CI/CD. It is possible by automating most of the stuff. Yeah. So that when you note a bug, you fix it, you test it, everything looks good, it goes into production. Like that, like that, like that. So that is how it happens. Next slide, please. That is what CI/CD is. I'm still waiting for you, Ian. Are you ready? How does one get projects to work on? Okay, that is your question. There are so many projects. If you go to GitHub, there are so many open source projects. But now the question is, some of them are not beginner friendly because you will get it's people trying to write plugins. There are people doing very complex, very complex things. Like Linux is people who are making changes to Linux kernel. It is an open source project that you can jump into, but it needs some level of, it is not beginner friendly. It is not somewhere you can start. So for you to know or get projects to work on, Ian, my advice will be this. In GitHub, there are all sorts of projects that exist, from machine learning to web development to everything, to anything that you can think of. Number one, you need to understand what you want to do in tech. Are you going into front-end development? Are you going into back-end development? Are you interested in IT automation like me? That is my interest. Are you interested in machine learning? What is your interest? After understanding what your interest is, then you need to understand what tools are needed for me to practice what I want to do. Yeah. For example, if you want to come into IT automation, you may need to understand how automation servers work. You may need to understand scripting, shell scripts. How do I write shell scripts? How do I write Python scripts that automate stuff? And stuff like this, yeah. If you're interested in development, web development, you may go into JavaScript. You may want to use Python using the Django framework or the Flask framework. You may be interested in, no, you need to understand where your interests are. That is the beginning point. And what tools I use, what languages do you need? And then you learn the language, you learn the syntax properly, you understand it, and then you learn the semantics of it, how you apply the syntax to achieve what you want. And then from there, you can start with very simple projects. And then depending on your interest, pole pole, you start building. When you start getting comfortable, now you can go into GitHub and get open source projects and even try you see if you can contribute to any. Yeah. And that is how you will be able to actually itaendelea kunini. Please clarify on the bugs fixing by software engineers using the CI/CD tools. Let me say the bugs are always there, and they depend on the kind of product that you're using. Yeah. If for example you are working in Safaricom or in M-Pesa Foundation, and you are developing the M-Pesa app, the M-Pesa app is always being fixed. It has some bugs that are always being fixed. Yeah. So the bugs that they handle at Safaricom might not be the same bugs that I handle at Greenpeace, for example, because at Greenpeace I deal with mainly I deal with the softwares that are used for ship navigation systems, and also some data analytics softwares that analyze data about the environment, environmental pollution and stuff. So we have data lakes, we do a lot of data analytics, and sometimes you can get yourself in a position where you need to fix some things regarding that. So I may not be in a position to point the bugs, what they are exactly, but it is something like some software is not giving the required results by the experts. Like we have environmental experts who are doing analysis for something using data, and they start feeling like this data is not giving us the expected results as we want it. As the experts, they know it. So then you will need to go back and look into your business logic and fix sometimes issues, those kind of issues. Yeah. For the ship navigation system, sometimes you get some ships are not communicating because of some issues to do with authentication. The captains in the ship cannot know where they are because the system is down for a reason of authentication, because there are security issues related to it. So you go in and try to fix that, and that is why our sprints are actually 4 days or less, because we support things that are actually in production, and some of them, they are critical. They can't wait for a month or 4 weeks, as it were, in generic Scrum sprint. Yeah. So that is what those are. I have really digressed and time is moving. I'm not even sure we are going to have our demo, but let me fast track this. The most important things I've already talked about. Yeah. What is a commit, which I've been talking about? Basically, a commit is a change to one or more files on a branch. When you change a branch or you add some value, some code into a branch, after adding it, for your change to be captured, you have to commit it, and we're going to see that shortly. Next slide, please. I'm going to go to rush a bit so that we can finish this in time. I have talked what pull request is. Is a mechanism to signal that the commits from one branch are ready to be merged into another branch. That is the simplest definition, and that is what it is. Yeah. Some different platforms use different terms. As I already told you, like GitLab uses merge request. Next slide, please. Cloning and forking. It usually confuses people. What is to clone? What is to fork? One leads to the other normally. Now, if you get a project which is on GitHub, it's an open source project. It is not your project. It is somebody's work. Yeah, and he has shared it publicly, meaning that you can fork it. So what you will do is you fork it. So after forking it, now for you to have it on your computer, you clone it. Yeah. Now, for example, you are in a team. Ukiingia kwa team, you will be added into a GitHub, a group in GitHub, and you will always have your permissions. So in this case, you don't need to fork it because you already have permissions. You can just clone it. Yeah. So basically, that is what forking and cloning is. Cloning is just basically getting the code from the remote repo, which is GitHub, into your machine, your local environment, and that's it. Forking is just saying, hey, I like this project, I want to use it. So you fork it and then you clone it. Simple. Next slide. So now we want to have a quick walkthrough. Julia, please, you can take us through. I see you've already done it. Actually, you are in a better position now to do it, even a presentation. So please go ahead.
All right. Don't worry. I think I can help you on that. Since you're already here, so maybe I can just do some stuff on GitHub. Then you will just let me know what I miss out on. So, for example, I think Maxwell shared about forking. So just to show you what forking is, I think he gave us the very good theory. So when you come to the practical bit of it, you fork when you want to like use someone's project. So in this case, I will just go to, I hope you can see my screen clearly, but in case you face any challenges, kindly let me know. So let me try and zoom in a little bit more. So as you can see, this is not my GitHub account. So this is Microsoft's repo, and they have this project. So let's say, for instance, let me use a different project because I've already forked this. So I'll just come to Microsoft's page. I will look at the repositories they have. And by the way, this is like an open source. So in case you're interested in just poking around, seeing the different projects you can contribute to, this is a good resource to go to. So let's say, let me look for something related to machine learning. So machine learning or AI, something like that. Yeah, so let's look at the workshop library. So let's say I'm interested in this project and it's something I want to use on my own. So as you can see now, I'm on Microsoft's account. So what I can do, you can see there's a button here that says fork. So I can simply just click on the fork button. And once I do that, you can see it will redirect me to my own account. then I can give it a name. So I'll just retain the repository's name, and then I will just say create fork. So once I do that, what I've done, now you can see that it no longer reads Microsoft, it now reads my account. So this means that I've just taken Microsoft's project, I have transferred it to my account, and I can now work on it. So what Maxwell was also talking about, cloning, this is when, remember, all this is online, this is on GitHub. Now what happens when I want to change something on this code? So I need to, like, let's say, use my local editor. So what I'm going to do is I'm just going to do like a clone. So cloning is basically downloading the project. So you can see you have the code button over here. So once you click on code, if you're a Visual Studio user, you can directly just click open with Visual Studio. But if you probably want to download it as a folder, and I think I'm going to share my entire screen because you won't have access to this. So let me just reshare and share my entire screen. Okay, so I've just reshared that. And so as you can see, I will just copy this URL. So if I want to just do a quick Git clone, I'm just going to copy this, and I'll just go somewhere to my file explorer. Let's say documents. And let's say I want to download, sorry, I need to zoom in. Sorry. I don't know if you're able to see this. So if this is where I want to like download that folder and make my local changes, so I'll just do like, you'll need to have Git installed. So probably Maxwell, you can share a link to where you can install Git. Then it's a very quick setup. So I'll just do a quick right click. Then I'm just going to say open Git Bash here. Then once I do that, I can probably, I think I will need, okay, I think I'm in the right location. So you just need to navigate to the location where you want to have your project saved. So then just do a simple git clone command, do a right click, paste, and then hit enter. So now, as you can see, the folder is already here. It's already downloading the components of that project to my local machine. Then once that is done, I will just open this with Visual Studio Code, make my changes, and then push the changes online. So that is how simple it is to work with GitHub. So far we've done forking. You take someone's project that you're interested in working on, you put it under your own account on GitHub, then you download it to your local machine, then you can make the changes you want, then re-upload it back to GitHub through push and pull commands. I think Maxwell also touched on that. So I think I'm just going to do like another quick demo because of time. So what I'm going to do, I think this is like the worst technical workshop you guys will attend, because there is literal homework. I mean, I have homework for you guys, and this is the assignment. So as you can see here, okay, let me zoom in. As you can see here, this is my resume, but it's online, it's on GitHub. So this is like everyone's assignment. Don't worry, there is a very interesting guide on how you can do this on your own. You just require 1 hour. But just to walk you through what happens, I'll just go back to my account. So I think I'll just redo this from scratch. So I will go to my account. I will create a new repository. So this is like a new project. So I know, Ian, you were asking, how do you get projects? Sometimes you don't even need to source projects. You can actually, just come up with an idea, then decide to implement it. So in this case, as you can see, I had done it before, but I'll redo it for the sake of those who are following. So if you have your PC with you, actually you can follow along, because you don't need to install anything for this practical bit. So if you have your browser with you, I would recommend just follow along, and in case of anything, let me know. Probably Maxwell, you can help me read out the questions on chat, because I don't have access to the chat. So I'll just go ahead and create a new repository. I will give it a name. So let's say resume 2. And if the name is available, you just see a green check here. Then give it a description, probably cool resume or something. Yeah. Kujichocha too. Then have it set on public. Ensure it's a public repository. So this just means everyone on the internet can see it. If you set it to be a private repository, not everyone will have access to it. The only people who will access it are those that you grant access. So for this particular project, ensure that you have it as a public repo, then add a README file, then go ahead and create that repository. So we've basically just initiated a project. So the other cool thing that you can do, as I said, you don't need to make any installations. So what you can do is on your keyboard, while you have this repository open, you just click the period button, like full stop. You just click on it and just have a look at what happens. So I have my my repository open. So this is my repo. I have just clicked the period button, and you can see that instantly the browser redirects me to github.dev. So that's like the code space GitHub. So that means you can actually, if you're familiar with Visual Studio Code, so this is definitely a view you're used to seeing. So this gives you access to the editor on your browser completely. So this just means in case you've left your computer at home, there is a quick project you need to work on, you can just walk into a cyber, just access this on your browser, finish up whatever you're doing, then go back home. I mean, it's as simple as that. So again, let me zoom in just a little bit. I hope this is actually visible to you guys. Yes, so we just clicked the period button on the keyboard. It instantly opens the github.dev code space for you. So the other thing we're going to do is install an extension. So if you're actually doing this alone, just type code swing. So we have this extension code swing. So just type and install it. You can have it. So for me, it's already installed. So in your case, you'll have an install button. So just click on it. This will help us see like a live preview of the changes we'll be making. So I think the other thing is probably have a file. So remember, we are creating our resumes. We need to like host it online. I mean, there's nothing that speaks more dev than having, having a recruiter ask you for your resume and you just point them to GitHub. So now probably you'll just call it index.html. Yes, and so I'll share a link with you. Oh, let me see. Yeah, so there's this workshop. So actually what we are doing, all this is available on this link. So you can see this video with these two interesting fellas from Microsoft. So they're actually doing like a walkthrough of what we're doing today. So in case you miss anything, definitely I'd recommend go back to this. All the resources we use for this practical, you can find them on this link. So actually, let me just post it on the chat for anyone who wants to like follow along. So it actually like provides the resources you need. So you can see this is the video walkthrough. In case you need to like access the code snippets, like let's say for now we're going to add the HTML outline of our resumes. So you can actually find like a code snippet for you. Everything is ready. You just need to go and fill in your details. So I had done that already. So in the interest of time, I'm just going to copy the code I had. So I'll just go back to our code space and then I will just paste that. Yeah, so I think something else we need to do on the settings. So Control-Shift-P. We need to initialize our workspace as Swing. So that's why we're installing the Swing extension. So use HTML only. Then you'll see that it's going to give us a live preview of what we're working on. So I don't know if you're still seeing my screen. Perfect. So I've just copied this is you're actually getting this sample code from the GitHub repo that I've just pasted on chat. So remember what you will do is just add your details, like you just add your name, and the change is instant. So you can see if you make any changes, it's instant on what you see here. So I'll also do that we'll add a second file. So you're going to add a CSS file. So we'll just call it style.css. There's also the available code snippet on the link I've just shared. So as I said, just 1 hour will be enough for you to do this on your own. And it's actually an interesting thing. You can learn a lot. So I'm just going to copy the CSS again, and you will see how that magically just changes the outlook of that resume. So once you've done that and you're content with how your resume looks like, remember the end goal is to have this hosted on GitHub. So what you can actually do is now commit. So back to what Maxwell was teaching us, this small icon here is source control. So you can just click on it and you can see the changes that we've made. So if I click on the style.css, you can see that before there was nothing on this file. It actually didn't exist, but now after the changes I've made, this is the code I added. And this is just basic, styling code. So it's really easy to understand code. So I can, if I'm content with that file, I can click this plus button. That means I'm staging that change. I'm telling GitHub that this change is now ready to be uploaded. So I'm just going to stage that. You can review the second file, which is the HTML file. I think I should have saved these files first. So I'm just going to do a quick Control-S. Then I'm just going to stage them. So you just confirm if everything is okay with the file you're working with. Just stage the changes. Then I remember Maxwell talked about a message, a commit message. So especially when you're collaborating, you need to provide a message that describes the changes that you've made, so that in case someone else goes back to that code, they'll be able to understand what exactly you did with that code. So I can just say initial commit. Yeah, so it's not as descriptive, but yeah, it's something. So another thing for Windows users, when you click the Windows icon plus the period, you get the emoji keyboard. So that's also something cool. So once you're content with the changes you've made, you just click this check icon over here. And that means you just commit and you push your changes instantly. Now, that is all you need to do. And you can now go back to your repository. And so this is now back on GitHub. This is the code that we've just created. As you can see, we have the README. So the final step is to actually deploy this to a page. So I just go to settings, then on pages here, I can select. So remember, we worked on the main branch. So I can just select main, then yeah, that's all. Hit save. And that is actually all you need to do. So in a matter of minutes, you have your resume being deployed. So as you can see here, there's a link that has been provided. So I'm just going to copy this. It's going to take a few minutes to deploy. So once that deploys, we'll be able to see that page loading here. So I will just go back to our actions. I think Maxwell also touched on workflows. So this mainly is, as he was explaining, you don't need to have like your managers or your code reviewers going through every single step. So I think I will just use the same illustration as Maxwell. Imagine you're working on a project, you're fixing 10 bugs in a day, you only have one reviewer, and you're working in a team of 5. So that means if everyone is fixing 10 bugs, those are like 50 pushes on GitHub. So does that mean that your manager needs to go through all that? No. So you can just set up like actions and workflows to automate the simple tasks that are being run. So as you can see now, the deployment is complete. So this is the workflow that was actually running to take our code and deploy it on the site, that on the URL that we have. And this is like a visual of what has just happened. So it built our project and then it just deployed it. So right now, if I go back to our site and I do a quick refresh, I should be able to instantly see my resume. And this is a link that you can share with your recruiters, you can share with your friends, you can share with potentially anyone. So I think that is the assignment that we're going to give you. As I said, this is a crappy technical workshop because you're going home with assignment. So everyone in the program, ensure you do this activity and you share your resumes even with your mentors, just for us to know that you successfully went through this workshop. I don't think we'll share a feedback form. So in case you have any feedback for us today, kindly let us know on, or you can use our Twitter handle or through your mentors. So I think having shared that, I'll just go back to the chat and see if we have any questions. Maxwell, in case something I left out.
Thank you very much, Julia. I think I have seen some questions that I want to jump on, but before the questions, allow me to have some comments. We have not seen the issue of branching through this demo, and I think it's very important. Normally, you would branch. You would create a new branch. You see, this normally you would go into a team and you will find they already have a product that is running in production. Yeah. So basically, what that means is you will start from a pre-existing branch. Yeah. So for you to contribute to that branch, you have to, for you to contribute into what is already in production, you will not comment directly into the main branch as Julie has done on this particular one. Yeah. You would actually create a branch, add your features into that branch, and then merge. Yeah. I work with Doris at Coding and Kahawa as the DevOps mentor. Julie has just shown us the pipeline. There is so much that goes into that. It is not from anywhere. Somebody sits down and writes that, and that is what actually my days looks like doing those things. I hope that in our DevOps session, if I will have a chance to, I may be able to take you through what a pipeline is and what it takes for you to write those automation stuff. How do you automate that thing? Yeah. I think those are two things that I wanted just to comment. But thank you very much, Julia. That was a beautiful presentation. And kindly, guys, take time and do this. I will jump on a few questions on chat. Write more questions. We have 7 minutes. We'll be concluding shortly. So the first question that I saw was, I can still do a quick show on creating a branch. Yes, if time allows. Let me answer the questions. If time allows, she will do that, but it is a pretty easy thing. Somebody's asking, are there limitations of use of Microsoft OS for the coding activities compared to Linux? I will tell you, if you want to go into coding, please learn some Linux. It is extremely important. All 90% of the servers are Linux. Yeah. Most of the things that runs in production runs on Linux servers. Most test environments are in Linux. Android is on Linux. So basically, do some learning on Linux. It's fine. You can do everything on Windows and still do stuff. But I'm a Linux person. I will always tell you, take your time and do some Linux things. Another question was trying to see, while Kelowna walked through the SSH, SSH, well, it is pretty easy. SSH is a way of securing your connection between your machine, your local machine, and your GitHub repo. You create some SSH certificate. It is very easy, and copy one certificate, the public certificate on the cloud, on the GitHub, and remain with your private SSH on your machine. So that when you initiate the communication, it needs to, but that is mostly for private repos. For public repos, you don't need to put an SSH key. For like this one, you want everybody to access, so there's no need for that. Another question, what is the difference between Git and GitHub? Git is a version control system. GitHub is a remote, it is a platform which is on the cloud that hosts your code. Apart from that, it has things like GitHub Actions, which does some automation, sort of an automation server. It also has, it provides a way where you can comment on somebody's work. You can see people's work and stuff. I had already discussed what that is earlier on this particular presentation. There is another question. Is a Telegram group available? I note one that I know of. I connected the SSH keys, but each time I push, I'm asked for my token. It should not be the case. It should not be the case. I don't know why it is asking for the token. Another question is, yes, what is it Git Bash and Git GUI? Okay. Git Bash is basically the Git CLI, command line interface. The way Julia did using the GitHub, the VS Code. VS Code has basically encapsulated or abstracted a lot of complexity with Git, because on this particular one, I'm assuming you know this GitHub is running from an image, and on that Docker image, they have already installed Git on it. So that is why from a few clicks on Visual Studio, you can actually run those commands using the clicks. Those are just some plugins that I've integrated. That is what you would do basically. But if you want to learn some Git commands, they are pretty easy. They are just straightforward. And sometimes you usually have the Git nightmare. Tunakuanga na you try to merge your stuff and there are conflicts, there are merge conflicts. That is where your commands will help you. But they're pretty easy. You can check on the Git documentation how to do that. Time is almost over. I think I need to comment on one thing, probably as we close. Julia, you can share the screen, the presentation on a few questions that are there. As I make this comment, there is something called Git Hooks. I think we can discuss this more in the DevOps session, but just to mention, in the software development ecosystem, there are things called Git Hooks. A Git Hook is now there are so many, but let me talk about the pre-commit Git Hooks. And I'm sharing a website on chat here that you guys should go and look at. And this is also part of your assignments. Share. This is extremely important if you want to set up your environment, your local environment, to be super, so that you don't waste a lot of time. Una commit changes into GitHub and then unapata nini. So there is a site, the precommit.com. The precommit hooks actually help you. You can write some scripts and have your environment in such a way that even before you write a commit message, even before you commit your stuff and it goes into the pipeline, yeah, it is already tested on your local machine. Yeah, that is a very cool thing. So that you already know that your code is going to work in the pipeline or not before even you do the commit. And that is the shifting left mentality that we are talking about in terms of software development. So please go and look what pre-commits are. So do some reading on it. See how you can create your environment and have a pre-commit environment, a very proper dev environment on your machine, so that you can really save a lot of time instead of waiting for somebody to look at what you've done, or waiting for the pipeline to run so that you can see your bugs. You can actually see your bugs even before you commit to a branch. Isn't that cool? Yeah, I think it's very cool. What is the best way to report a bug to a GitHub project? Yeah. Do you send an email to a owner, I don't bother reporting bugs? Or do you search for the bug of the project's existing issues and create a new one? You will see every project has an issue. Any project that has an issue, it means it has some bug. So the best practice is you search for the bug in the existing issues and create a new one if it is not yet reported. Because we are in the dev, this is a dev environment. Sisi ni madevs. Tunasaidiana kama umeona bug, unai-report so that the maintainers of the project can actually fix it. Yeah. Next slide, please. Suppose you have created a bug and you fixed and if you want to contribute into it, what do? You create a pull request to merge your new branch into the main branch. That is what happens. If you've identified a bug or you've gone to a project, it has issues, you've seen the issue, you can fix it, you just create a branch, try to fix it. From the issue, you create a branch, and then create a pull request from your new branch. If you fixed it, it should be accepted and you could have contributed in fixing bugs, and that is how you contribute to open source projects. And this is what I would encourage young people like you people who are in school. Start getting involved in open source stuff and contribute to the community. Kidogo kidogo tu. Yeah. Next question, and I think it's the last one. Suppose you'd like to work with a project on GitHub, but you don't have right access to the project. What can you do to contribute? Yeah. What you do, you fork the project to your GitHub account, and that is exactly what Julia did. Clone the Flow project to your local machine, and then you push changes to your repo and submit a pull request to the target repo. Yeah. So basically, you fork, you clone, you commit the changes into your branch, and then you create a pull request, and that is how you contribute to that project. Yeah. So I think that is it. So the summary is, in this module, you've learned about what GitHub is, how to use GitHub with GitHub Dev. It is just that period thing that Nani ametuonyesha vizuri sana. You've learned about commits, branches, and pull requests. And this is what you would work with on a daily basis as a dev in a team. I hope you like the presentation. Next slide. I hope you like the presentation, and looking forward to seeing you guys. So these are some materials where you can actually learn more. And then the last slide, please. I think you can get this slide afterwards.
Okay, Doris, do you have anything to share? I don't know if Doris is still with us, but because of time, I think time is far much gone. Thank you so much, Max, for showing up and for the wonderful presentation. I think this was super helpful, and probably I've just seen a comment from Steve. I think we are yet to touch on hooks. So I think the best way, because time is really much gone, probably we'll have that as we'll share a written summary of what we've done today with the recording for anyone. Probably we're going to slot in something on hooks. So don't worry about that, Steve. I will definitely look into that and ensure that we address it in the resources that we're going to share after the call. So again, thank you so much to everyone that's really spent time to be with us, and hopefully you'll be able to work on your cool projects on GitHub. In case you have any follow-up questions, in case anything was not clear, please get back to us with the feedback on how we can even improve